Okay, so here's the third question for mapping linked genes, and remember all these are from the homework. I didn't put the stuff from the optional. I'll start doing the optional afterwards, but let's focus on this. Anyways, so I was saying, so in this question, if you guys read it, it's when you walking on the subway, you find this new unknown species of rodent, and they have the following characteristics, right? So when you look at this, actually, if you notice for parental groups, you kind of have the 9 to 3 to 3 to 1. So here is your 9, almost 300, almost 300. And then here's your 1. So this, just when you look at this ratio, you know you're dealing with 2 chromosomes. Okay. Another way is, I said, you're going to color your parental groups. So here, coloring them up, you're going to go like, oh no, but I have only 2 parental, like these. Okay, I think pink is too dark color. So you would have lumped these 2 together of being close to each other, but then you're going to go like, oh my god, but this one is a huge number. Don't let it scare you. It's just, it doesn't really matter that it's a huge number. Actually, you actually have 4 parental groups. Usually the parental groups, the numbers are close to each other, but then in this case you have the, again, 9 to 3 to 3 to 1 ratio, so it confirms that you're working with 2 chromosomes. So you know that those 4 are your parental groups. Okay? So again, if I was to do step 1 after finding this out, I would say, oh, how was I saying? I would say, how many chromosomes do I have? I'll do 2 to the power. First I'll say I have 4 parental groups, which means I had 2 to the power 2, which means I'm working with 2 chromosomes. Again, just confirming that case. And then, just by looking at the parental group, you will notice something. You will notice the ones that keep traveling with each other. I noticed that Wispy, it's too dark, I apologize for that. I noticed that Wispy and Hairy, right, always travel together. The only one that's creating the difference is Brown Eye, and here I have Pink Eye. So that's what's creating the difference. Okay, then what I notice as well is that, let me do Pink Eye in a different color. Okay, but then what I notice as well is I have thick whiskers, I don't know why, yeah, thick whiskers and hairless. Thick whiskers and hairless, they always travel together. Then I have brown and pink being the different ones. Okay, so when you notice that, you know that if these 2 always travel together, and these 2 always travel together, and brown and pink are the ones that are the deal breakers, you know that brown and pink are on their own independent chromosome. Okay, so if they're on their own independent chromosomes, that means wait a sec. Yeah, so that means that here you have brown versus pink. They're on their own chromosome. So for brown, I'm using this convention. For pink, I'm using this one. And then for wispy whiskers, for me to determine wild type and non-wild type, I should have looked at Where is it? Apologize for not pointing that out. So the parental groups, here they tell you that the female was wispy whisker, pink eye, hairy female. Oh, sorry. To determine which one are the dominant traits, actually, I would look at the big one. So I know that brown, when I look at 9 to 3 to 3 to 1, the 1 in the 9 is actually the one that has the dominant group, right? So I know brown is dominant to pink. I know that wispy whiskers are dominant to thick whiskers, okay? And hairy is dominant to hairless. So usually I'll put this as my wild type, this one is my wild type, and then these are like my mutants. So I'll just call this W and I'll call this H, and I'll just put pluses for the other ones. Anyways, so for wispy whiskers, I said I'll just put it as positive. For the hairy one, I'll put just positive, and then for the other ones, for thick whiskers, W, and for the hairless one is H. So I know that these are on the same chromosomes. I know that these are going to be on the same chromosomes. I hope that this does not confuse you. So again, if I was to do the dominant patterns for the trait, those were my dominant patterns. Write them out. I'm just putting letters just to go really fast, but you heard me say them as I'm putting the letters, so you know which one I'm talking about. What are the genotypes of each parental groups? Which, if any, of the genes are linked? So we figured it out. We figured that these two are the linked ones. This is on its own. Again, I'm doing this assuming that you read the question. And then what are the map distances between them? Okay, so I figured out that since wispy whiskers and hairy rodent always travel together, that means that they're cis on the same group, and I called them wild type for that. And then thick whiskers and hairless rodent always travels together, that means not same group, on the same side of the chromosomes, though they're cis to each other. So that's why here I have the thick and hairless together. Anyways, so if I know that's the case, if I have a single crossover, let me draw this. Right, if I have a single crossover, I have a hairless one, okay, with a wispy whiskered one. So where is my wispy whisker? Here's my wispy whiskered. And yeah, since I know that these are on its own chromosomes, I don't care about them. I don't even have to do single crossover. So let me just erase these as if they do not exist, right? If I erase these as if they do not exist, because they're on their own chromosomes, again, we're trying to reduce amount of time. Hairy rodent wispy whisker, hairy rodent wispy whisker, so I will add these two numbers together because they represent the same group. I'll add these two numbers together. Wispy whisker, hairless rodent, wispy whisker, hairless rodent. I'll add these two numbers together. Thick whiskers, hairy rodent, thick ones, hairy rodent. I'll add these two together. Right? So this will give me 4. This will give me 2. If I use the relative frequency equation, RF equals to single crossover plus double crossover over total times 100, I do not have a double crossover because I only have one gene, so I can only have a single crossover, right? So forget about this one. So it's gonna be equal to, my single crossover is 4 plus 2. My total is, does it tell me the question? No, it doesn't. So I have to add it on my own. So this is 10. This is 400. These two. I know I should have done the calculations before starting this. I'm sorry. What am I thinking? So 0, 9, 1 plus 400 plus 10. 107,000. I mean 1,700. Okay, so it's 1,700 times 100. These go together, and then you'll just find the answer, which is 6 over 17. Just use a calculator, and that would be your map unit, the distance between W and H. That's it. Hope you found this video helpful. Hope I didn't confuse you a lot, and I apologize if I did.